Hey, what's up, everybody? It's Ned Bellavance, Ned1313 on Twitter, and welcome to the Daily Check-In for June 18th, 2020. Wow, we made it to Thursday, everybody, and you know what that means. It's Thursdays on the edge. We're all living on the edge, I suppose. A little Aerosmith throwback there. If you're too young to remember that song from Aerosmith, or too old, I guess it could go either way. Count yourself lucky, not their proudest moment. But anyway, uh, today's topic is going to be edge networking on the edge. And I think I'm going to do like a little tour of traditional networking up to the impact that things have had on networking, with edge kind of being the most recent impact, but certainly not the last. We could even talk about networking in space, but I don't think I'm going to get to that in this one. So, okay, before we do that, a couple housekeeping items. I've decided that Fridays are going to be about HashiCorp Vault. I've had a couple people request that I do some Vault content since I'm pretty deep in Terraform and I've done some Vault courses on Pluralsight. And there's a Vault certification out there. So let's do that. I'm basically going to cover one of the objectives for the certification every week and go a little in depth about information you would need to know to get through that objective. So hopefully that'll be helpful if you're thinking about doing the Vault course. And I'll put them all in a playlist so you can watch them straight through if you want. It won't be as good as a course, but it'll be something, right? I may also write a guide at some point as well. The other thing is that I am going away for a week at the very beginning of August. And I was thinking about what I could do with the daily live stream. Now, I could just pre record a bunch of stuff and post it out, and that's an option, but it's not a super exciting option. I thought that a more interesting one would be one of two things: either to have someone else do the live stream for that week, or have different people do the live stream each day, or just have some people pre record a segment for each day and I'll do like a little intro roll on it, and that'll just be published throughout the week. So if that sounds interesting to you and maybe you want to contribute content, reach out to me and let me know. I'm certainly interested, and I think it would be a fun exercise and something I could do every time I go on vacation, given that's not often, but I have to do it every once in a while, right? Ooh, I didn't turn my sign on. Let's turn my sign on. Aha, open for business. Okay, so before we get into today's topic, I just want to check in with you. How you doing? We made it to Thursday. Thursday. I've heard Thursday called a lot of things. Thursday is a good one. I like Thursdays on the edge. I hope the week has not been too tumultuous for you. Another good T word. And that you're gearing up for the weekend and getting ready to do whatever you need to do. So that's a quick check-in, but I think I've already burned enough time with the intro. So let's get right into the topic, which is networking at the edge. So to provide a little context, a little perspective, let's say, on networking in general and specifically traditional IT networking. In the early days, and as people built out their environments, you generally started with a central data center. And then there was this concept from Cisco that you would have layers to your networking. So you'd start with a core, and then you had like a distribution layer, and then you had an access layer. And so the distribution layer was to distribute your networking out to all the people who would consume it, your end clients, and your end clients would actually hit the access portion of that. So you would have your core routing and switching environment that would hook into your distribution switches, and then beyond that you've had your access switches. And that's kind of what your networking looked like in a data center and maybe an office campus kind of thing. And as networking evolved and changed, the networking in the data center changed a lot, moved to sort of a spine and leaf architecture. And we're not going to get into that right now. Probably not the right person to talk about it anyway. But beyond that, what started happening was the building up of the WAN, the wide area network, to interconnect multiple sites that are part of an organization. And so you'd have these campuses that were connected through private circuits, usually MPLS lines. And so these were dedicated circuits that you got from an ISP. And that was fine. They were very expensive and they weren't especially fast, but they were dedicated to you, which meant that you had reliable bandwidth and reliable latency and jitter. So that was generally a good thing. And that's kind of where things stayed for a while. And what you had was a lot of branch offices that would send all of their traffic that was bound for the internet or really anything else back to these central hubs. So you kind of created this hub and spoke architecture where if I was in one branch office and my computer needed to talk to a resource that was in another branch office, it would go back to the central data center and then back out to that branch office, wherever it was. And that's not particularly efficient, but probably not a huge deal. Anything that was internet bound, instead of going out of an internet line at my branch office, would backhaul to the central office, the data center, and then go through whatever security stack was in place, all the inspection engines, the IDPs, and their firewalls, and all that kind of good stuff, and then go out and come back in that way. So it wasn't the most efficient way to direct traffic, but it was a way to centralize and control the flow of traffic. And that made sense for that era of networking and computing. And then what came along? Well, two things came along. One is the cloud. And the cloud really messed with things because now you had this additional data center, or as it appeared to you, multiple data centers that were deployed out in somebody else's cloud environment. And you had to hook that into your existing environment using tools and terminology that you were totally unfamiliar with. And that did throw people through a loop, and it continues to do so. But it didn't totally change the flow of traffic. It just meant if someone needed to access a cloud resource, now instead of they still weren't going directly to that cloud, they were probably still going through the central data center, through the security stack or whatever it was. And then maybe you had an express route, like an MPLS circuit to the cloud, or you were doing site-to-site VPNs and it would go that way. So you were still connecting that way. And then another thing that came along that really inverted the traffic patterns was SaaS. So think about Microsoft Office 365. Think about Google G Suite. Think about all these services that don't exist in your data center. So you've got all these clients sitting in your network and also all these clients sitting at the branch offices, and they want to communicate with G Suite and Workday and Trello and all these online SaaS applications that exist in the public internet. And all of that is going through your central office. Whereas before, the traffic patterns were mostly stuff coming down into your central data center. Now you've got a lot of information going up, and it really changed the communication patterns. So what happened is companies like Zscaler came out and other ones that created this distributed proxy layer where you could start sending your traffic out. It's called local breakout from your branch offices. This will tie back to Edge at some point, I swear. But I need to tell this whole story for perspective. And so that traffic, instead of going through your central data center, was now decentralized. You had a distributed point of management with these Zscaler and other proxy type services. But then they were going out of the branch office directly through this distributed proxy into whatever cloud service they want. And the circuits in your central data center weren't getting hammered anymore because you'd moved where that traffic was coming from. So that's all the stuff that happened before the edge started creeping up. Now the edge hasn't fully hit. It's kind of like you can see it in the horizon. You see the wave coming, but it's not here yet. But you got to prepare yourself because edge is going to do what SaaS and cloud did times 50. So instead of people talking to computers and websites, now you're going to have machines talking to machines. You're going to have all these edge devices that need to talk to something up in the cloud or talk to something in your data center. And instead of 100 users, you're going to have 1,000 devices or 10,000 devices. So think about that increase in network utilization. The flow of data is going to be up. It's going to be flowing from those devices upstream through your different infrastructure layers and potentially to the cloud. So whereas before you were mostly pushing content and data down, that whole thing is inverted. It's going up. Those machines are probably going to want to talk to each other as well. So what you're going to want is robust inter-site networking, kind of like how instead of having one branch office go through the central DC to talk to another branch office, same thing, if you've got devices here and devices over here in the same metropolitan area, you don't want them to go backhaul to a central office or a cloud to talk to each other. You want them to just talk directly to each other. So you need robust intersite networking in that region to do that. Like I said, you're going to have hundreds or thousands of additional nodes. So, what do you absolutely have to have in your edge networking? Well, you have to run IPv6. I can't really see a way around that. As you expand the number of devices on your network, that 10 dot address space doesn't work anymore. And that is awful. You're going to have to go IPv6. I don't see any way around that. Another one is you're going to need software-defined networking and SD-WAN. I don't see people are already moving away from using MPLSs. Now they want to use commodity broadband and use an SDN platform to connect all that stuff. And you're going to add all these additional potential sites. You're going to need some sort of software-defined networking to manage all of these sites. How is it going to manage it? It's going to be automation and policy driven. There's no more going in and manually configuring routers and switches at this extreme level of networking and device count. You need something that can roll out in an automated way, a configuration update or a security update or whatever it's going to be. So those are all things you must have. And I think the last thing I want to say, and this is probably a topic for a whole other edge discussion, is where does security sit in this stack? Because it sounds like it's a confusing jumble of devices and locations and intermediaries all talking to each other. Where does security live in that whole stack? And that's a question that is still being answered at the moment, so we don't know. But hopefully that gives you sort of a primer for like where networking came from and kind of where it's going and how edge is drastically impacting that networking structure for the edge. And that's all I got for today. Tomorrow, like I said, is going to be my first in the series of HashiCorp Vault videos. So if that's of interest to you, make sure to tune in. It's going to be very similar to the Terraform videos, except I want to really go objective by objective for the Vault exam. So maybe I'll do a high level of what Vault is and then start, delving into the objectives. So that will be tomorrow. But that'll do it for me for today. Thank you so much for watching. Thank you for listening. Stay healthy and stay safe, everybody.